Friends, welcome to my tutorial. Let's directly get to the point. We have simple C program that we created and we are going to guess its license key by angr. Okay, so let's first play with it, entering any random values. Of course, that's what we expected, right? Basically, it's used that logic that cannot be guessed by a normal user. Okay, so let's first analyze it using radar and let's seek a main function where exactly it's checking if else conditions for that grant or prevent access keys. As you can see here, after checking that condition, if it's true, then uh, it's go to access denied if it's false, and if it's true, that it's just going to check if it's granted or not. So remember this address. Okay, that's what we are going to use in angr. So let's get started with angr. First, you need to create a virtual environment in Python. That is best good way to use an angr in it. So let's activate. Make sure to install it by pip install angr. So let's start it now. I have already installed it. So let's try import first import angr. Okay, and then import clarify. That is a symbolic execution for it. Let's first load the binary part where you can load directly a that executable simple crackme that we created. Dot slash simple crackme. And next we have to add this in anchor project. Okay, so let's add it. Prog is equal to anchor.project and binary path, and by default we have to make sure that it doesn't load any different libraries. So autolabs is equal to false. Since we don't know the exactly length of it, so we're going to try password it random length. Let's try with 25 and let's create a symbolic variable for that license key. Clarify.bvs, it's a bit vector for this license key where key length into 8 represent the number of bits since 1 byte is equal to 8 bits. Okay, you can enter any license label to make it easier for reference variable. So let's add a new line. When we first enter dot slash simple crackme, then we have to enter pass any random keys, then press enter. So this is for it. So let's add a simple slash n for new line. And then concat with clarify that where license key is simulated, entering the key. Now let's create initial state for this symbolic input. This sets symbolic stdi in our input data for entering user license key in new line. Next, we have to add okay, let's add first. Next, we have to add a simulation manager which controls the symbolic executions. That it is working symbolically, exploring the different paths based on constraint and conditions. Now let's find the target offset. We have target offset. Through that, we tell angr to follow date, where follow date means it is the exit offset where angr need to look and don't look, don't have to look order offsets. Uh, Object offset, this offset is found, then we are going to simply print it. This retrieves our first successful state from the founded paths. Okay, so let's just print it. Oh, okay. Now key found a solver evil is it's a angr solver date symbolic license key and returns its concrete value. Cast it to the bytes, and then just print key. Print key, valid license key. Else license key is not found. So that's it for this Anchor script. Let's now run it. And then that's what expected. Never runs at first time. I know. Maybe we looked offset is correct, but let's make sure it by printing let's find when program compiles, it's dynamically does not generate different target offset. So let's make sure. It's just a simple, it's finding in main function if its offset exists or not. Address offset. And as you can see, it's not exist. Why? Because when I use GCC compiler, then it's automatically generate position independent executable PIE. So when you compile code to prevent reverse engineering, it uses dynamically generated different offset. As you can refer it to Wikipedia, you can see a PIE in using GCC compiler, it's generating different offset. So let's now try to print it proper offset this time. You can use a mapped base plus target offset that we can, it's every time different when you try to compile and run it. When you try to run it, main object dot map dash it's every time different when you run it program. So now we are generating our offset dynamically. So let's comment it and use direct target address. here. Let's run it. Yeah, now we got success, but what is this? Some gibberish values that not we can understand, right? But this is a simple directly a byte. So let's now properly print it by splitting it. You can see in value lessons ki printed the first value is looks correct, like in after it looks incorrect. So let's try proper split it and print the correct value. uh, we need to split, so let's try key dot split. Okay, let's try a key dot split from that x00, and the first array, first successful state from founded path. Split it from x00. Okay, 0, then decode it. And yeah, we got our valid license key. Now let's copy it and run it in our simple Crackme. Let's exit radar. And yes, valid license keep access granted. That's what you wanted, right? So let's now try again, expecting different value now. So this is the random values that generated by our made that mathematic logic. So yes, now we successfully able to print unguessable by normal user. So that's the power of anger. It can print exact value if it properly guided. So this is it for the video. If you have any Android app that used to validate license key, let me know in comments. And if you want Android tutorial on it, then I recommend Fatal Sec, link in description. Thanks for watching.